Download this code from codegive.com, link in the description below. Understanding diffusion versus auto-regressive models. Diffusion models and auto-regressive models are two different approaches used in generative modeling, particularly in the context of image generation, text generation, and other tasks. In this tutorial, we will explore the key differences between the two, and why diffusion models often outperform auto-regressive models in certain applications. What is diffusion? Diffusion models are a class of generative models that learn to generate data by simulating a diffusion process. The basic idea is to start with random noise and gradually refine this noise into a coherent data sample through a series of steps, or iterations. The model learns the reverse process of a diffusion that corrupts data by gradually adding noise. Key characteristics of diffusion models. Stochastic process, they model the gradual transition from noise to data. Iterative refinement, they refine samples through multiple steps, allowing for high-quality outputs. Training via denoising, the model is trained to denoise corrupted data. What is auto-regressive? Auto-regressive models generate data by predicting the next value in a sequence based on previous values. These models are typically used in tasks like language modeling and speech synthesis. They generate one token, or pixel, or data point, at a time, conditioning each prediction on the previous tokens. Key characteristics of auto-regressive models. Sequential generation, they generate data one step at a time. Conditioning on history, each prediction is based on all previously generated outputs. High computational cost, longer sequences can lead to increased computational overhead. Why diffusion works better than auto-regressive models. 1. Parallel generation, diffusion models can generate samples in parallel across multiple steps, while auto-regressive models generate sequentially, which can be slower. 2. Quality of outputs, diffusion models tend to produce higher quality samples due to their iterative refinement process, allowing them to better model complex distributions. 3. Less exposure bias, auto-regressive models suffer from exposure bias, where the model is trained on a fixed dataset but generates sequences in a different distribution during inference. Diffusion models do not have this issue as they iteratively refine samples. 4. Robustness, diffusion models are often more robust to noise and can generate samples that are more diverse and realistic. Code example. Here is a simple code example to illustrate the difference between a diffusion model and an auto-regressive model. For simplicity, we will use pseudocode to outline the concepts. Diffusion model pseudocode. Python. Import numpy as np. Class diffusion model. Def__init__, self, time steps. Self.time steps equals time steps. Def forward_diffusion, self, x0. Corrupt the data x0 by adding noise. Noise equals np.random.normal, 0, 1, x0.shape. Return x0 plus noise. Def reverse_diffusion, self, xt. Refine the noisy data back to the original data. For t in reversed, range, self.time steps. Apply denoising step, this would be a neural network in practice. Xt equals self.denoise, xt, t. Return xt. Def denoise, self, x, t. Simple denoising function, placeholder. Return x*, 1 to 0.1 t, just an example of refining the data. Example of using the diffusion model. Diffusion_model equals diffusion model, time steps equals 10. Initial_data equals np.array, 0.5, some initial data. noisy underscore data equals diffusion underscore model dot forward underscore diffusion, initial underscore data. Refined underscore data equals diffusion underscore model dot reverse underscore diffusion, noisy underscore data. Print, refined data, refined underscore data. Auto-regressive model pseudocode. Python. Class auto-regressive model. Def underscore underscore init underscore underscore, self. Pass. Def generate, self, initial underscore sequence, length. Generate a sequence one step at a time. Sequence equals initial underscore sequence dot copy. For underscore in range, length. Next underscore token equals self dot predict underscore next, sequence. Sequence dot append, next underscore token. Return sequence. Def predict underscore next, self, sequence. Simple prediction function, placeholder. Return sequence -1 plus np.random.normal, 0, 0.1, example of generating next token. Example of using the auto-regressive model. AR underscore model equals auto-regressive model. Initial underscore sequence equals 0.5. Generated underscore sequence equals AR underscore model dot generate, initial underscore sequence, length equals 5. Print, generated sequence, generated underscore sequence. Conclusion. In summary, diffusion models offer several advantages over autoregressive models, including better sample quality, robustness to noise, and the ability to generate samples more efficiently. While both approaches have their strengths and weaknesses, diffusion models have gained significant attention in recent years for their performance on various generative tasks.